Example 3. Evaluate each series. Let's take a look at the series in example A. Okay, so as soon as you see this, the sigma notation should signal to you that you need to add all the terms up. So the terms of this sequence are going to come from this expression, okay, j squared plus j plus 1. So that means j should be the index of summation. So if we look at the number below the sigma notation, we need to start adding up the terms at the first term, and we need to add all the way up through the fifth term. So basically, we're adding the first 5 terms of this sequence. So what we're going to do here is we're going to compute each of these 5 terms, and then we will add them up. All right, so let's start with n equal, j is our counter here. So let me erase n, let me put j instead. Okay, so we're going to start with j equals 1. So go to our expression here, and we're going to plug in 1 for j. So 1 squared plus 1 plus 1, that's going to give us 1 plus 1 plus 1, that's 3. So that tells us the first term of the sequence is 3. Okay, so now we just need to keep bumping j up by 1 until we get to 5. So let's bump up j by 1. So we're going to go to j equals 2. Go to our expression here. Everywhere we see j, replace it with 2. We're going to get 2 squared plus 2 plus 1. So that's going to be 4 plus 2 plus 1. That's going to give us 7. So that means the second term in the sequence is going to be 7. All right, bumping up j again to 3. Go to the expression, replace j with 3. So we're going to get 3 squared plus 3 plus 1. That's 9 plus 3 plus 1. That's 13. So the third term in the sequence is 13. All right, we keep going. Now j is 4. Okay, so we're going to replace all the instances of j with a 4. We will get 4 squared plus 4 plus 1 to get 16 plus 4 plus 1. That's 21. So the fourth term in the sequence is 21. And then the last term we need to compute is given by this number right here. So we just need to go to the fifth term. So we're going to let j be 5. So plug in 5 for j. We're going to get 5 squared plus 5 plus 1. That's going to be 25 plus 5 plus 1. So that's 31. The fifth term is 31. So now that we have all 5 terms, we have to add them up to get what the series converges to. Okay, so we need the answer to this, so we have to add everything up. This is going to be a1 plus a2 plus a3 plus a4 plus a5. Okay, so I'm going to go to the calculator and add this up. So I've got 3 plus 7 plus 13 plus 21 plus 31. Okay, here's your answer. Okay, the answer to this question is 75. Okay, I found the first 5 terms of the sequence, added them all up, and the answer is 75. Okay, so we can also say that this series converges to 75. Okay, when you add everything up that you're supposed to add, the answer is 75. Okay, so that's all you have to do to evaluate a series. Okay, let's try the series in part B. Okay, this one's going to be a little different. Obviously, we have a different expression. Our index of summation is given by k this time, but something you might notice immediately is that the lower limit of summation is a negative number. Okay, it's not a counting number. -1 is not a natural number, and that's okay. Okay, we're still going to treat this like we normally would. Okay, we're just going to start at -1 and then keep going up by 1 until we get to the upper limit of summation, which is 2. Okay, I did mention to you when we were first discussing summation notation, it is possible that your index of summation starts somewhere else other than 1. You don't have to always start at 1. And as you can see here, it is possible to have a negative number. Okay. All right, so here we go. We know the terms of our sequence are going to be given by this expression. Make sure you realize here that only the 2 is raised to the k power. Basically, the 2 is what's in parentheses here. So when you look at this, the 5 is not raised to the k power. This is basically 5 times 2 to the k power. So the 5 is just multiplied out front. All right, so what we're going to do here is we're going to start at k equals -1. This is our lower limit of summation. That's where we start, okay? So the first k value that we're going to have here is -1. So we're going to plug in -1 for k to get the first term of the sequence. So this is going to be 5 times 2 to the -1, okay? So this is going to be 5 times. Remember, a negative exponent means you can do 1 over the something, but you change the sign of the exponent. So this is going to be 5 times 1/2. So the first term of the sequence here is 5/2. A1 is 5/2. If you want, it's a nice decimal, so you can go ahead and make it 2.5 if you wish. Okay? All right, so what do you do now? Okay, where do you go? Do you go to 1? Well, think about it this way. Okay, think about a number line. Okay, if we're on a number line, let me move this up here for a second. Okay, so if we're looking at a number line, okay, we're starting with -1, and then we go to 0. That's the next integer. Then we go to 1, then we go to 2, then we go to 3, and so on. So we always bump up our k value by 1 unit. Okay, so let me erase this. Let's go back down here. Okay, so after k is -1, we're going to go to k equals 0. So we'll keep raising our k value by 1 unit until we get to 2. Okay, so now we're going to plug in k equals 0 into our blue expression. We're going to get 5 times 2 to the 0 power. That's going to be 5 times anything to the 0 power is 1. So this is just going to give us 5. Okay, so the second term in the sequence is 5. Now we're going to bump up to k equals 1. Plug in 1 for k. This is going to be 5 times 2 to the first power. This is going to be 5 times 2, which is 10. So the second term, or sorry, the third term in the series is going to be 10. Okay. All right. We need to go one more time to a k value of 2. Then we stop because that's our upper limit of summation. Plug in 2 for k. So we're going to get 5 times 2 squared. This is going to be 5 times 4, which is 20. So the fourth term in the sequence is 20. So to get the answer for the series, we need to add up these 4 terms. Okay, so this is going to be 2.5 plus 5 plus 10 plus 20. And that will give us our answer. Okay, so I'm going to go back to my calculator, type this in. So I'm going to have 2.5 plus 5 plus 10 plus 20. So we will get 37.5. You can do math option 1 to convert it to a fraction. Okay, so either answer is correct, 37.5 or 75 over 2. Okay, that's the number that this series converges to. Okay, so again, I can say that this series converges. Why does it converge? Because I can add it up to a number. I can pinpoint the exact number that the series adds up to be. Okay, remember I told you every finite series is going to converge. Remember, this is a finite series, as was the series in example A, because we added up a countable number of terms, okay? So this particular series converges to 37.5, which is the same thing as 75 over 2.